Okay.
All right. So now on this one, you know what we need to do next. So in order for you to understand how the redox reaction works, we'll go through what you did in grade 11. Then we'll come and use the information to answer this question. Everything that we're going to do, we'll come back and answer this question. By the end of this lesson, you need to be able to determine the oxidizing agent and the reducing agent in each of these following reactions, okay?
Okay.
Using the oxidation numbers. Okay, so now, once we're done, we're gonna do the half cells, which is this. We're just gonna use this. Can you see my screen, right?
Mm-hmm.
Okay, so I don't want us to waste time. Let's go through this, these things. Né? So now remember, we have what we call what is this? We have what we call, they say that the redox stands for the reduction oxidation. Okay?
Yeah.
But the purpose of this lesson, we are here to talk about what? Electrochemistry. So I think it's best if we start by explaining what is electrochemistry. Do you have an idea what is electrochemistry?
Yeah, electrochemistry, right, has to do with, I know, the forming of, it's almost like when things move from this side and then they go to the other side and then they fill up there. They use it also when with jewelry. I
Okay.
know, like
Remember,
fake jewelry stuff.
you know the word that I was looking for from you.
What?
It's the interaction between electrical energy and chemical energy. That is the study of electrochemistry. So electrochemistry is the study of interaction between electrical energy and chemical energy. I'm not sure if you're still with me on that. Do you understand what I'm trying to say?
Yeah.
Okay. So we are saying that this electrochemistry is the study So it will be between what? It will be between electrical energy and chemical energy. Né?
Mm-hmm.
Right. So now that you understand what is electrochemistry, the interaction can happen in two ways. Né? So the first one, the chemical reaction can be used to produce electrical energy. This will happen in galvanic cells. Né?
Mm-hmm.
Yeah. So what I'm trying to say is that the chemical reaction, so the chemical reaction we can be used to produce electric electrical energy. You understand?
Okay.
And this it's what will happen in galvanic cells. So we'll talk about galvanic uh, cells on our next on our upcoming lesson. Yeah? Okay.
Okay.
Right. So we're saying that the interaction can happen in two ways. The first one is when the chemical energy used to produce electrical energy. The next one is when electrical energy uh, can be used to cause a chemical reaction. Okay.
Mm-hmm.
right, to cause a chemical reaction, and this will happen in electrolytes. Okay,
Mm-hmm.
it's simple. This will happen in electrolytes. Okay, so now, in order for you to master this topic, you need to understand the redox reaction. Okay,
Mm-hmm.
right. I will go back to that. What we okay, let's go to the redox reaction. We need to make sure that you are familiar with this topic, then yeah, we'll take everything from this. Now, so we are saying that the term redox stands for reduction, oxidation. So oxidation can be identified as gain of oxygen or loss of hydrogen. Okay,
Okay.
but I'm just gonna put it in simple terms. Now, so redox reaction. When I talk about the redox reaction, so this has to do with what? This has to do with this involving, it's a reaction involving transfer of electrons. Okay?
Okay.
Okay, transfer of electrons. Are you happy with that? Okay, so now we are saying that the most important definition is given in terms of electrons. Oxidation is loss of electrons, and reduction is gain of electrons. Okay,
Mm.
so now in terms of this, there's something that I want us to maybe pay attention on. Something like saying, when I say I need you to understand what is a reducing agent and what is a oxidizing agent, because we need this to answer that question. Remember, I said we're going to answer this question before the end of this lesson. You need to be able to understand what is the oxidizing agent and what is the reducing agent. So I'll definitely explain it. So I think it's best if we just put this side, né?
Okay, sir.
And say the reducing agent, and then you also have to understand an oxidizing. So this one is a reducing, and then you have to understand an oxidizing. Okay, so this one, you see this one is a substance that donates electrons. Okay, so it's a substance that donates electrons. So now, if it donates an electrons, we say it undergoes oxidation. So it will
Mm.
undergo oxidation. Are you babysitting?
No, sir, it's busy in the house. Like my sisters are still going to school, so it's a
Oh, yes. Okay. So now, and then an oxidation agent, this one, it will be a substance that, this one, it will accept, né,
mm,
electrons. And then when it accepts, we say it under
cause reduction.
reduction. Okay, I'm just gonna put it there, and then let's go back and complete what we were working on. So now, one way of according for electron is to use oxidation numbers. You need to understand how this works. Né? So I'll just, without wasting time, I think it's best if we just go straight to the oxidation number rules. So tell me, do you understand how these rules work?
No, you can do it all.
Eh?
No, do it all.
Okay, so now you see the oxidation number rules. The first rule is that the oxidation number of an uncombined element. Do you know what is an uncombined element? Give me one example of an uncombined element.
No, I don't know what's an uncombined element.
Okay. Just give me 5 seconds, and then you'll definitely understand what is an uncombined element. Né?
Mm.
When I give you something like S, you see, it's
Mm.
just sulfur. You
Mm.
understand?
Okay.
It's just like sulfur. Then it's an uncombined element.
Okay.
You understand? So it's just we call this the pure and diatomic element. So this is pure and diatomic. So this one, instead of saying uncombined element, this is pure substance, pure and diatomic. Diatomic. What do you guys call this? Uh, Diatomic elements. So what do you guys say? Mahamba yedwa. Is
Hi.
that what you guys say? Umahamba yedwa.
Uh,
Eh? When
yeah.
someone is singing, you
Mm.
guys say umahamba yedwa.
Yes, sir.
Yeah, and another example of pure, another example of pure element, I can give you Na. You see, Na, sodium, umahamba yedwa. You
Mm.
understand?
Mm. Mm.
So now, when I write it like this, sodium chloride, you see, it's no longer pure because this is
Yes.
the combination of sodium and chloride. It's no longer a pure and diatomic element. You understand how
Yes,
this
sir.
goes? Are you happy with that?
Mm-hmm.
Yeah. You see, now you understand the first rule, né?
Mm-hmm.
So the first rule is that uh, the oxidation number of an uncombined element is zero. And then now, certain elements have fixed oxidation number. This is where I need your attention. Ne?
Okay.
Right. So this is where I need your attention. So now, uh, all group one elements are plus one. You know where to find group one.
Yes. On the
You know
periodic
where's group
table.
one. Should we indicate that on your let me just maybe you need us to indicate it on your what is this uh, on your periodic table. I'm just looking for the periodic table. Okay, unfortunately this one we need to. Okay, so look at this now.
Mm.
This is my group one. You see, this
Mm.
is group one.
Mm.
All elements in that group according to the rules, né, they will have
Mm.
an oxidation number of plus one. You understand?
Oh yeah, yeah.
Okay. So what this rule is saying is that uh, all group one element they will have the oxidation number plus one.
Plus
So
one,
if
yeah.
if if I give you H2 and I ask you what is the oxidation number of H2, it depends if H2 is a pure or diametric element. Don't worry, everything will make sense. So if
Mm.
you just have to check in which group is that whatever count element you're working with, okay?
Yeah.
And then all group 2 elements are plus 2,
Yeah.
okay? And then now, hydrogen, it's always plus 1 except in hydrides. You'll see when we do examples. So hydrogen, it's always plus 1. Fluorine, it's always minus 1. You see this fluorine. Do you know all the halogens? Ne? If you did organic chemistry, still
Yes,
remember
the
the
halogen.
halogens like
Yes.
fluorine,
In chlorine.
Cl,
Mm.
uh, bromide. You see all
Iodine.
the halogens, they are to the power minus 1. You understand that part?
One. Yes,
Okay.
sir.
So now oxygen, it's always minus 2,
Two.
except in peroxides, what, and when combined with fluorine. So if I give you an oxygen that is combined with fluorine, it won't be minus 2. But oxygen is always minus 2. Please, I know that most of these rules will make sense when we do examples, okay?
Okay, sir.
Yeah. So chlorine it's always minus 1 except when combined with fluorine and oxygen.
Yeah.
Then now, you see all these rules on group 2. Don't worry about those rules. We'll go through them when we do the examples. Now, the most important one, number 3. The sum of oxidation numbers in a compound is always 0. If this does not make sense, wait until we do examples. You'll understand everything. The last one, the sum of oxidation number in an ion always adds up to the charge on that ion. Okay, let me give you something. We know that Zn is Zn, it has the charge of +2. You understand? What is this? Why am I saying? It has the charge of 2 plus. I think you know that, né? So Zn, it has the charge of 2 plus. So they are saying that the sum of oxidation numbers in an ion. So if you get Z2 plus the oxidation number, it will be the charge of that ion. So if I give you maybe magnesium chloride, which is also 2 plus, you know that the oxidation number of that ion, because when you have a charge on top, we call it an ion. So the oxidation number of an ion is that ion, is the charge of the ion. You understand?
Okay, sir.
Let's do example. Let's try and work on example. I'm just going to explain this example one so that you can get how this works. Né? So the
Okay.
question says that you are given sulfuric acid. Is this sulfuric acid, right?
Yes.
H2SO4. This is sulfuric acid, right? And let's say they ask you, what is the oxidation number of sulfur in sulfuric acid? Right. So remember, okay, let me take this step by step. I don't want to get like too much excited, because if I get too much excited, you won't be able to understand the concept, you know. So now, when I have something like this, the first thing that I'm going to do, I know that I'm going to write this in this form using this law number 3. Look at this law number 3. Law number 3 says that the sum of oxidation numbers in a compound is always 0. And the compound that I'm given is sulfuric acid. So I have 2 what? 2 of hydrogen. You see what I did there?
Mm-hmm.
I have 2 of hydrogen, and this act with what? With sulfur, and this is what? I'm just trying to check how did we do that sulfuric acid. 2 hydrogen molecules, and then sulfur, and then 4 of oxygens. Are you happy with this? That step?
Yes.
Then the sum, look at this. The sum of oxidation numbers in a compound is 0. So when we add the oxidation numbers of this, we should get 0. You understand?
Okay.
So next thing that you need to do is to identify what is this? Is to identify the oxidation number of H. So if you go back, they said that hydrogen, it's always +1, except in hydride. So the oxidation number of hydrogen, it's +1. So I'm just going to say this is 2 into +1, plus the sulfur is the one that we are looking for, plus 4 into, what is the oxygen? And when you go this one, oxygen, it's always -2. So the oxygen is -2. So the oxidation number of oxygen is -2, and this should be 0. So when we work this thing out, this will be 2 times 1, that's 2, and then plus S minus 8 is equal to 0. You solve for S. So this will be 2 minus 8, that's S minus 6. It's 0. Therefore, what is sulfur? Plus 6. So the oxidation number of sulfur in sulfuric acid is +6. This is what they are trying to explain in this example. Are you happy with that?
Yeah.
Eh?
Yes.
You understand how this works, because it's very important.
Yes, I get it.
Okay, so let's work on the next example. Let's say we need to find the oxidation number of sulfur in S2SO8 minus 2. Look at this. This compound is an ion. Why? Because of the 2 minus. You see, it's an ion because of the 2 minus. So remember, we said that we have 2 of sulfur. It reacts with what? It's hydrogen. This is H2. This is H2. So now we have 2 of hydrogen that reacts with S,
Yeah.
and then we have 8 of oxygen. Okay, this is equals to, remember the law that we're going to use is law number 4. The sum of oxidation number in an ion always adds up to the charge of the ion. So we need to, when we add them, we should get the charge of the ion, which is minus 2. You understand why I'm equating that to minus 2?
So why do you have a hydrogen?
Why? Oh, what's going on? I'm sorry. And at first I did it right. You remember?
Yeah, that's why I was confused.
Ish.
Lord.
Okay, let's rewrite this. This will be S2. It's S2O8. So now we have 2 of sulfur plus 8 oxygens, and this thing, this is an ion because of the minus 2. So when we add this oxidation, we should get the charge of the ion. This is law number 4. The sum of oxidation number in an ion always add up to the charge of the ion. You understand that part, okay?
Yes, sir.
And we are looking for the oxidation number of S. So I'll just leave that as 2S plus, we said oxygen is always minus 2. So oxygen is minus 2, it's equal to minus 2. Solving for S, I have 2S. This is minus 16. It's equals to minus 2. So the minus 16 will go to the other side to be positive 16. So that's 2. This will be 2S. It's equals to, the 16 comes this side to be positive 16, which gives us positive 14. Divide both sides by 2, divide both sides by 2. Therefore, the oxidation number of sulfur in that S2O8, 2 minus, I always like to write this wrong. So this is positive 7. So this is how they got that positive 7. You understand?
Yes, sir, I get it.
100%. So let's do more examples of that. You can see if there's something new that you need to know. So the oxidation number of chlorine in, so now we are given sodium. I don't know what is this, but it's fine. Now look at this. We have sodium, and then sodium, then we have Cl, we have 3 of oxygen. Okay, so when we add this, we should get, this is just something, it's not an ion, so this should be 0. So when we add all this, so I think the difference, you see, if it's an ion, we equate to the charge of an ion, but if it's not an ion, the sum of the oxidation number should be equal to 0. So now sodium is in group 1. So if you look at, they said that all group 1, so sodium is in group 1, so it will have plus 1. Okay, so sodium is in group 1, and I'm just gonna substitute that. Where is it? I'm just gonna substitute that as 1. Then plus chlorine. We said chlorine it always be minus 1, and then plus. Oh, what are we looking for?
We're looking for chlorine, sir.
Okay, so we can't substitute chlorine, eh?
Yes.
Okay, we can't substitute chlorine. Okay. This will be plus Cl plus 3 oxygen. It's always minus 2. So it's 1 plus Cl minus 6. It's equal to 0. And 1 minus 6, that's Cl minus 5. It's equal to 0. Therefore, the chlorine will have the oxidation number of plus 5.
Yes.
So in this compound, the chlorine will have the oxidation number of plus 5. Ne? So now the last one, the oxidation number of Mn in MnO4. So it's Mn, that react with 4 oxygen. But look at this. What is this equals to?
What's it's
Look
equal
at
to
this. The
negative one
charge is
percent.
minus. It's minus. We have the charge that is minus on top there. I'm not sure if you can see that. Can you see the minus?
Mm-hmm.
You can see that, ne?
Yes.
Yeah. So now this will be equals to -1. Then Mn is what we are looking for, and we said that oxygen, it's always -2, -1. So Mn, it will be, this is -8, it comes to the other side to +8. Therefore, Mn will have the oxidation number of +7. You're
Yes.
still with me on that?
Yes.
You understand that part, ne?
Yes.
Okay. So now that you understand this, there are some of the concepts that we need to go through so that I can be 100% sure that you are ready for this. I just want to know if we're doing this or what, ne?
Okay. So.
Okay, so now I'm not sure if we should do maybe more examples or what, but it's fine. Look at this, ne? So if I have the magnesium chloride, we know that the magnesium chloride is a neutral compound, ne?
Mm-hmm.
Right. So since it's a neutral, the sum of the oxidation number should be equal to 0. And let's say we need for magnesium chloride. So this will be the magnesium chloride. It reacts with 2 of the Cl. Then we equate this to 0. We are looking for this. And then now remember, oh, this is just Cl. And then this will be Mg plus 2 into Cl. It's always -1. Therefore, this tells you that the oxidation number of Mg, this will come this side to be +2. So it will be +2. You happy with that?
Sir, can you please go up to the rule? There's something I need to see there.
Or the rules?
Mm.
Uh-huh.
There's something. 2021. Okay. Okay.
All good.
Yeah.
Okay, okay. If you're happy, then I guess we can just move on. Ne? So
Yeah.
now, look at this. Ne? I want us to okay. So now that you understand that, let's talk about, remember I said that if I have something like this, we said the reducing agent is a substance that donates electrons and it will undergo oxidation. Can you please give me a second?
Okay.
Okay, so now remember we said that a reducing agent is a substance that donates electrons. Né? So now look at this. We said I want us to summarize something very fast. Né? So when it comes to reducing agent and oxidizing agent, we said oxidation, this guy, it's loss of electrons. And then reduction, gain of electrons. Okay? So now I need you to know what happens if an oxidation number increases. Do you know what happens? Yes, if oxidation number increase. No, if the oxidation number increase, this tells you that the oxidation occur. Né? So if an oxidation number increase, that's oxidation. And if an oxidation number decrease. Then this will be reduction occurs, okay? So this will be reduction. You'll see how this works. Let's read the question now. But before this question, I want to give you maybe one example that we can do. Let's say I'm given magnesium that reacts with bromide. Okay, so look at this. And then let's say these two, they form MgBr. So when you look at this, we need to understand, because the question here is asking you use oxidation numbers to identify which one is the oxidizing agent and which one is the reducing agent. So what you need to do first, you need to, let's identify what will be the oxidation number of that magnesium. Tell me. I want you to tell me what is magnesium, the oxidation number. Is it plus 2? Look at the equation. Hmm? For this one, tell me what is the oxidation number for this one. Let's go back to the rules. Now, remember, oxidation, the rule said that oxidation number of uncombined element is 0. It's a pure and a diatomic element. It's a pure element. Okay, so it's a pure element, and when we say it's a pure element, you can see that Mg mahamba yedwa. Come on, Emihle. So listen, my Chomina. When you say it's 2 plus, you can say it's 2 plus in this one because this one is not a pure element. Asima hamba yetwa. So this tells you that this side, the magnesium will have that plus 2 because it's in group 1. Group 2, right? Exactly. So yes, when it is combined with that bromide, that's when it's gonna be plus 2. But this side, it's on its own, and we said that the oxidation number of an uncombined element is 0. You understand? You get it? Please, Bone. If you don't understand, please tell me. I don't mind to explain this again. You see? Okay. Uh, this example with Mn. This one. Okay. Okay. Let me explain that, my dear. Ne? Don't worry. Ne? I got you. Look at this. We got the magnesium to have the oxidation numbers plus 2. Ne? Why is it plus 2? Because it's not it's a combined element. It's magnesium combined with chloride. That's why it's plus 2. But now, if I write it like this, I say magnesium plus Cl2, they form MgCl2. So this tells you that on the reactants, the oxidation number of Mg, since it's standing on its own, it's 0. But this side, it's a combined element, it will be plus 2 because it's in group 2. But if you don't know which group, this is the method that you can use to calculate the oxidation number of Mg. You understand? You get it, ne? Yes. So even this side, when I say what is the oxidation number of chlorine, it's 0 because it's not combined to anything. But this side, since it's combined to anything, we need to check. We set the oxidation number of chlorine, it always be -1. I hope you understand what is going on here? We good. Okay, so now if we go back to this example, and now look at bromide. We said that bromide, all the halogens, they will have this one bromide is standing on its own, it's uncombined element, so it will have the oxidation number of 0. Then, but this side, the bromide is combined with Mg, so it's gonna have the oxidation number of -1. You understand? So let's say you prefer to use the formula to calculate this. You know what you can do? Let's say you want to find the magnesium, the oxidation of magnesium in that Mg Br2. You can use that formula that we talked about. So we know that MgBr2, it's a pure element. Since it's a pure element, when we add the oxidation number of Mg with the oxidation number of 2 of that Br, we should get 0, right? So Mg plus 2 of, and we know that the bromide is just -1, since it, according to the rules, or we can check which group is that, but I'll just go to the rules because I don't want to confuse myself. I know that the rules, they said chlorine is -1, so we know that chlorine is part of those halogens. So all the halogens, they will have -1. So bromide is also part of the halogens, which will have -1. That's why I'm substituting -1. Therefore, Mg -2 is equal to 0. This gives Mg to have what? To have +2. So this is where the +2 is coming from. But even if you know that Mg is in group 2, then no need for you to go through all this problem. You can just write +2. Are you happy with that? 100%. Okay, so now when you look at this, when you look at that Mg, look at the oxidation number. It starts from 0, then on the product it's +2. So this tells you that the oxidation number increased. So we said that if the oxidation number increased, what will be Mg? So this tells you that Mg is oxidation, so it's oxidized. You understand? So it will undergo, are we saying this right? Okay, so we are saying that an oxidizing agent is a substance that accepts electron and it undergoes reduction. Okay, let me say this again. Mg is from 0 to +2. So the oxidation number increased. So this is oxidized. So Mg, it's oxidized. Since it's oxidized, it's an oxidizing agent, and then it will undergo what? I'm not sure if it's a, what is this? If it's oxidized, it's a reducing agent. So oxidation, then it will be reducing agent. You know? So Mg, it's a reducing. Exactly. So now when you look at the bromide, this one is for Mg. So when we look at the bromide, the bromide starts from 0, then it becomes -1. So the oxidation number decreased. So we said that if it is decreased, it's reduced. Reduction, it's reduced. Okay. Since it's reduced, it's an oxy. Is that making sense? You understand? Then I guess we just have to work on this one. Let's work on this example. The first example here, that example A. Let's first write this down. We have, I'll write it down for you now. Do you understand what is going on here? Okay. So the first one, we have the sodium that reacts with H2O, and then this forms Na2O plus H2. I did not change anything. This is what is given. You can see that, ne? Okay, so let's first start with the reactants, ne? Let's start with the reactants. We need to write the reactants and then the products. Because we need, let's first start with the sodium. What is the oxidation number of sodium? Exactly, mahamba yedwa. So this is an uncombined element, so the oxidation number is 0. And then what about hydrogen? Look at this. Hydrogen is in H2O. It's plus 1, but it's not like, yeah, it's plus 1 because it's combined. You understand? It's plus 1. And I think you still remember the other way to confirm this. We say if I have H2O, I can use the formula and say I know that 2 of that H react with O, and they should give me what? 0. Okay, then 2 of H, I know that is just plus 1, and oxygen is minus 2. Oh, I'm sorry, we are looking for H next. So this will be 2 of H, 2 of that H, then we add that minus 2, this should give us 0. So this will be 2H, then the 2 comes to the other side, divide by 2, therefore H is just plus 1. You understand how we got that, right? 100%. So now, we did for this, we did for H, the last one, it's O, the oxygen. So look at this, the oxygen is combined, so it's always minus 2, right? Let's go to the products. Let's go to the product. What is Na? On that Na, NaO, Na2O. Yes, exactly. Na is in group 1. So it's plus 1. Why? Because this side Na is uncombined, and we said that the oxidation number of uncombined elements is 0. And then Na is now with oxygen. We need to check which group is Na. That's in group 1. Then it will have plus 1. Then what about, let's do hydrogen. What about hydrogen? Mahamba yedwa, can you see? H2. So it's 0, it's uncombined. Then oxygen, since it goes with NO2, then oxygen is always minus 2. You understand? So now, looking at this information, if you still remember, the question said, identify, use oxidation number to determine which one is the oxidizing agent and which one is the reducing agent. So now, to do this, look at this. Oxygen was minus 2, then the product is also minus 2. So nothing, we can't say nothing changed on that one. Ne? And then now we need to look at the sodium. Sodium, the oxidation number of sodium changed from the Na, it changed from 0 to 1, to positive 1. And we said that if the oxidation number increased, this will be oxidation. It has lost electrons. So if the number increased, this tells you that this is lost electrons. And then this is gain electrons. So this tells you that when it's like this, the oxidation number of the Na has changed from 0 to 1. Therefore, it has lost electrons and it will undergo oxidation. So since it's oxidation, therefore we can conclude and say Na is therefore the reducing agent. You understand? And then what about the oxidation number of hydrogen. So we can see that the hydrogen is from 1 to 0. So since it's from 1 to 0, the number of the number of oxidation number decreased, then this will be reduction. Okay, so it will be reduction. Since it's reduction, therefore we can conclude and say H is the oxidizing agent. Okay, you know what I'm going to do next? Okay, but in most cases, what I need you to note is that on the reactants, you'll always have the reducing agent and the oxidizing agent. Okay, we're good. Should we do the next one? Number B. And then I'm gonna leave this one for homework. Né? You can practice that one. Let's work on number B. Number B, we have H2S plus SO2, which gives us H2O plus S. Let me write that down. Then we'll definitely work on that. H2S, it acts with SO2. They form H2O plus S. So remember, we need to identify the reactants and the products. Okay, so first thing first on the reactants, let's start with H. Né? So H, look at this. It's with S, it will be +1, right? And then what about sulfur in H2S? What will be the oxidation number of sulfur? You know what you need to do. We work it out. So I know that if I have H2S and I'm looking for the oxidation of S, I have 2 of H that acts with S, they should give me 0. And H, we know that is just 1 plus S, which is 0. This will give us the oxidation number to be -2. So S will have -2. You still with me? Then now we need to find for S that is in SO2. So for that S, what is that? We do the same. So for SO2, this will be S that reacts with 2 of oxygen. They should be equal to 0. That is X plus, this will be 2 into -2 is 0 because O is -2. Then this gives us S to be +4, né? Because it goes to the other side. So S will be +4. The last one is oxygen. So what is oxygen in this one? Oxygen, we know that it will always be -2, right? Okay, and then let's go to the products. I think we need to the oxidation number. It depends. Yes, it won't be the same. It depends on that S it's in which compound. You see this S, it's combined with H2. This gives us the oxidation number of -2. In this compound, it's combined with O2. This gives us a different oxidation number. So you have to do this calculation. You understand? And then let's move to the products. So when I look at the products, I can see that the first one is hydrogen. And we know that hydrogen is reacting with what? with H2O, so it's just plus 1. And then the next one, it's, I'm listening. Okay, so the next one, it's sulfur, which is something that we don't have, so it will be 0. And then another one for this one, remember we are trying to pair these things, né? So this one we can use for that one. So for this one, still it's 0 because mahamba yedwa. And then oxygen, so as oxygen, it's always -2. So as it's always, for oxygen, it's -2, right? So nothing happened on H. I'm just going to scratch that. And then nothing happened on, wait. Oh, and nothing happened on O, ne? Maybe we can just scratch that for now. And then let's look at this S. So this S, this one, is the one that is on H2, ne? So the S on H2, it's from -2 to 0. So this tells you that for H2O, there was increase in number of what? In number of the oxidation number of sulfur has changed from -2 to 0. And we said if there's an increase, what is this? If there's an increase in the number of oxidation, this will be oxidation, loss of electrons. Né? So this tells you that H2O, no man, why are we saying H2O? H2S. See? H2S. So this one will be oxidation. Né? So since it's oxidation, H2O, it will be our reducing agent. You understand that one? And then for this S, which was the one for SO2, so this one is from +4 to 0. It's from +4 to 0, which means that we gained, it's from +4 to 0, loss of electrons, the oxidation number went down. I'm sorry, gain of electrons, the oxidation went down. Né? This tells you that this is reduction. And then this will be our oxidizing. Therefore, SO2 will be our oxidizing agent. Are you happy with how we did these examples? Yeah, I wanted us, I guess the half cells reaction will start them in our upcoming lesson. For today, not for, for now, let's stop on this part. Then on the upcoming lessons, we'll talk about the half cells reactions. So we'll take this step by step. Okay, and that's it for this lesson. I hope you understand how this works. Did you take notes? You want me to send you notes, or you have your notes, né? Okay, nah. Thank you very much. Thank you. I'll see you on the upcoming lesson. Bye-bye.